Okay, the first word that you need to write down is sequence. And a sequence is a list of numbers that often forms a pattern. What? Yeah, you're being recorded. Yeah, right now. Okay, the next one is term. So each number in the sequence is called a term. Okay, and then the last word is arithmetic sequence. I know, it looks like arithmetic, but it's not. It's a little bit different. Arithmetic. It's a lot of fun. Say it. Arithmetic. It just like rolls off your tongue. Arithmetic. All right. So when the terms of a sequence differ by the same non-zero number, the sequence is called an arithmetic sequence. Okay, so if they change by the same amount each time, then it is an arithmetic sequence. All right, so we're going to determine on example 1 if it's an arithmetic sequence. So what you're looking for to see is, does it change by the same amount each time? So from 12 to 8, how does that sequence change? Minus 4, right? So we put that there. And then from 8 to 4, how does that change? Minus 4. And then from 4 to 0, how does that change? Minus 4. So because it changes by the same amount each time, then we would say, yes, it is an arithmetic sequence. All right, so let's look at example 2. That's it. Yep. That's like 7th grade math. I know y'all have done that for a while. Okay, so on example 2, what's the change from 1 to 4? What does it change by? 3. And then from 4 to 9, it changes by 5. And then from 9 to 16, it changes by 7. So is that an arithmetic sequence? Nope. Doesn't change by the same amount each time, so that one's a no. Sure. I don't know what you mean. Okay, now on example 3, it says determine whether each sequence is an arithmetic sequence. If so, identify the next 3 terms. Okay, no, it's not bad. Okay, so here's the thing. You have to determine what the difference is between -3/4 and -1/4, which I didn't really mean for that to be difficult, but there were some people earlier today who couldn't tell me what the difference was. So here's how you find what the difference is. But you do like this. You take the second term and then subtract the first term. So in your calculator, here's what you put. Okay, on the home screen, you do your fraction, and the second term is -1/4, and then we subtract the first term, which was -3/4, and you push enter. So the difference between those two is 1/2. Okay, then we want to know what the difference between -1/4 and +1/4 is. So we put the first term, or the second term, which is 1/4. Nope. It's a negative. And then minus -1/4. So the change there is 1/2. And then from 1/4 to 3/4, what would that be? That would also be 1/2. So is this an arithmetic sequence? So because this is an arithmetic sequence, we have to find the next 3 terms. So on your paper, I want you to do like this. Make a spot for 3 more terms. 1/2 and a/2 are the same thing. 1 and a/2 is different than 1/2. Yes. Did that just blow your mind? Okay. All right, so what do we want the difference between 3/4 and the next term to be? 1/2, right? So in my calculator, what I will do is I will put 3/4 plus 1/2, which is 5/4. So here, my next term would be 5/4. And then we would add 1/2 again to get the next one. So the next term is 7/4. And then we add 1/2 again to get the last term. Which is 9/4. Okay? Now, oops, wrong thing. Okay, so when I look at example 4, oops, see, I don't know what's going on with my smartboard today. It's being kind of weird. Okay, on example 4, what is the change from 2/3 to 1/3? Yes, Cole? Yes, because it changed by the same amount each time. Example 3 was an arithmetic sequence. Okay, so let's get back to example 4. From 2/3 to 1/3, what is the change? Does it go up or down? Yeah, it'd be minus 1/3, right? Okay, then from 1/3 to negative 1/3, how much does that go down? Okay, so that goes down 2/3. So I can basically stop right there. Because these numbers are different, that means no, this is not an arithmetic sequence. Okay? So I want you guys to take a second, and I want y'all. All right, so on example 5, you should have gotten the difference between -4 and -2 was +2, because it goes up. From -2 to 1, the difference is 3. And from 1 to 5, the difference is 4. So because of that, no, that is not an arithmetic sequence. Okay, then on example 6, there it goes. Huh? Oh, I'm sorry. I don't know. Let's do example 6. Shh. All right, so from 4 to 1, the difference is -3. From 1 to -2, it's -3. And from -2 to -5 is -3. So it decreases by -3 each time, which means that it is arithmetic. So I have to find the next 3 terms. So for the next one, I should subtract 3, which would put us at -8. Subtract 3 again, which would put us at -11, and subtract 3 again, which would put us at -14. Okay? Now, so here's where what we learned yesterday and what we learned today come together. All right? In example 7, it says find the 22nd term of the arithmetic sequence. Now, it is going to take forever for you to sit there and write out to the 22nd term. And if you look at example 8, it wants the 49th term, okay? So it would take a really, 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 really long time for you to find the 49th term. But I would teach you a shortcut that I would prefer you use. However, if you get to like the STAR test or a quiz or something major and you can't remember the shortcut, you have to do like fill in the blank, okay? So I would suggest just learning the shortcut. All right, so here it is. On example 7, it wants the 22nd term. So would you all agree with me that 5 is the first term?
Yes.
Okay, so above the 5, because it's the first term, we're going to put a 1. So everybody do that. Okay, then above the 2, we're going to put a 2 because it's the second term. Above the -1, we're going to put a 3 because it's the third term. And above the -4, we're going to put a 4 because it's the fourth term. So what we just did was kind of make like a makeshift table, okay? These numbers are going to represent our x's, and these numbers are going to represent our y's. And we're going to find a function that fits the pattern. So we make a table, like what we did yesterday, x, process, y. So our x's are going to be 1, 2, 3, and 4, so I put them here. And then our y values are going to be our terms. So 5, 2, -1, and -4. So from 5 to 2, what happens on our y values? Goes down 3, right? And from 2 to -1, it goes down 3. And from -1 to -4, it goes down 3. And what's happening over here with our x's? It goes up by 1, right? So then I need to find my change in y over my change in x. So the change in y is -3. The change in x is 1. And then I can reduce that whole thing to -3. So -3 is my rate of change. So I put it here. I multiply it by the x value, 1. So -3 times 1 is -3. And how do I get from -3 to 5? What would I have to do? No, not plus 2. From -3 to 5. You plus 8, good. So plus 8 would give me 5. Okay. Then -3 times 2 is -6. But I need for the answer to be 2. So plus 8 again. -3 times 3 is -9. Plus 8 is -1. -3 times 4 is -12. Plus 8 is -4. So what is the function that fits our arithmetic sequence?
Y equals -3x plus 8.
Y equals -3x plus 8. Now, there's a couple things you can do. First thing would be to take the 22 and plug in for x and solve. That would be the easy way, okay? Or the way you know, I guess. But I think that the easier way is to go to your y equals and type your function in. So the function is -3x plus 8. I type that in. And then I want to know what 22 is, right? So, well, if you push second window and type in 22 and then go to your table, it takes you right to it. So when x is 22, y is -58, which means that on example 7, your answer is -58. That's the answer. All right, can I change the screen? No good? Oh, wait, let me go back that way. Okay, so then on example 8, we're trying to find the 49th term, which would take a really long time to write out. Okay, so we're going to say 7 is the first term, 10 is the second term, 13 is the third term, and 16 is the fourth term. So we put it in a table, x, y, process, and 1, 2, 3, 4 go in the x column, and 7, 10, 13, and 16 go in the y column. And then we try to find our change in y over our change in x. So what is our y value changing by each time? 3, good. And then what is our x value changing by each time? 1. So we put 3 over 1, which reduces to 3. So I take the 3 and I put it here. So I say 3 times 1 is 3, but then we need for the answer to be 7. So to get from 3 to 7, we plus 4. So then we try that again. 3 times 2 is 6, plus 4 is 10. 3 times 3 is 9, plus 4 is 13. 3 times 4 is 12, plus 4 is 16. So what's our function that fits the arithmetic sequence? Y equals 3x plus 4. So I can type that in my calculator. I'm going to go y equals, and type in 3x plus 4. Second window, because that'll take us to the skip button. Okay, and we want to skip to number 49. So when x is 49, y is 151. So for this one, you would say your answer would be 151. Okay, now flip over to the back. Now these back ones, there's a way to make them like difficult, but I'm going to show you like the easy way. It's like probably 4th or 5th grade math easy, okay? It says the odometer on a car reads 60,473. Every day, the car is driven 54 miles. What is the odometer reading 20 days later? So here's what you do. Every day, they drive 54 miles, right? And the odometer reading in 20 days, what would I do with 54 and 20 if they drive 54 miles each day for 20 days? Multiply, right? So I would do 54 times 20. So what is that? What is 54 times 20? 1,080. Okay. And then when we started, the car had 60,473 miles on it. So what would we do? Add it together, right? So 60,473 plus 1,080 would give us a grand total of how many miles? 61,553 miles. And that's it. That's your answer. See? Easy. All right. And then number 10 says each time a truck stops, it drops off 250 pounds of cargo. It started with a load of 2,000 pounds. How much does the load weigh after the 5th stop? So for this one, each load is 250. And how many loads are they dropping off? 5 loads, right? So I would do what with 250 and 5? Multiply. 250 times 5, and what does that give me? 1,250. Okay, and then originally the truck weighed 2,000 pounds, so how do I figure out how much the truck weighed after 5 drop-offs? Subtract, good. So 2,000 minus 1,250 would be how much? 750, good. So that one's my answer, 750. 750. Thanks, Julio. All right, so we've got a little bit of time left. If you guys want to go ahead, get out your notebook paper, we'll get started. Homework 4.7 is on page 275.